Hello everyone and welcome to a new video, and in this one we will have an example on while loops. The example is related to the so-called Fibonacci sequence. So let's first read the example statement. Uh, it says use a while loop, write a MATLAB script that prints the first few terms of the Fibonacci sequence whose values are less than 1000. So we need the values less than 1000. Hence, Fibonacci numbers are the sequence of integers in which each term is the sum of the previous two, with the first two terms are 1 and 1. We are also asked not to use arrays in this example. So let's do it step by step. So apparently the first term is 1. We call it f sub 1 is 1. Also f sub 2 is 1. And if we keep going, the third term is 1 plus 1, which is 2. Fourth term is 2 plus 1, which is 3. Fifth term is, so let's see, 3 plus 2 is 5. Term number 6 is 5 plus 3, that's 8, and so on. So we would like to print on the screen the terms that are less than 1000 in the Fibonacci sequence, and we are also asked not to use arrays. So we really have just to display. So let's start with what we know. We have a file here, it's called Fibo, using a while loop. We need to list what we know so far. The first term is 1, and the second term is also 1 in Fibonacci sequence. And now I need to do some sort of a while loop, and obviously every while is gonna end somewhere. So let's think about an algorithm to do this. One way to look at it is I can start with f1 and f2, and because I want to print all the terms in the sequence, I will really be displaying f1 always. But then I need to sort of march in the sequence. So let's see. So supposedly the sequence is like this. The first term is 1. The second term is also 1. Third term is 2. Term number 4 is 3. Term number 5 is 5. Term number 6 is 8. And I think the next one is 13. Next one is how much? 21, and so on. So initially, this f1 is located here, and this f2 is located here. So I can try to march in the sequence such that in the loop, I can actually make f1 to take this value next, and then f2 takes this value next. And then I move forward one more time. Then in the next step, this will be the new f1, this will be the new f2, and then I march again, this will be f1, and this will be f2, and so on. So I can, in a sense, march and use the variable f1 and f2. But to calculate the new f, to calculate the new term of the Fibonacci sequence, I will need an extra variable. We could, for example, call it f new. And whatever I'm going to display on the screen will always be f1, because f1, as you see, will cover all the terms below 1000. You see, they started from the very first one, and then they move forward to the next one, and then to the next one, and then to the next one. So in a sense, I can just display this one, and I can make the condition of the while loop based on it. So here, it will be while f1 is less than 1000, I'm going to display the f1, right? And then I need to do the next calculation for the next term. So let me, for example, call it f new. The new f is just f1 plus f2. But then, upon calculating f new, I need to do the marching, the progression along the sequence. And that's basically by saying that the new f1 is just the old f2, and the new f2 is f new, This way we are progressing. In fact, let's, before actually running this code, let's actually try to trace it a little bit. We can get a new page here. So before we enter the while loop, I have f1 equals 1. It's color here, light green, and f2 equal 1. And so far, f new hasn't been calculated. And maybe here I'm going to see what's going to be printed on the screen. Then we will display f1. So display f1, so this line here, sure, I'm going to display, so I will see the value 1 on the screen. And then I will calculate f new. So f new now is calculated. It is just 2. And then according to this line, the new f1 is f2. So f1 becomes f2, which is 1. And the new f2 is f new, which we just calculated. That's 2. And then we reach it to the end of the while loop, so we go back to the start of the while. Is f1 less than 1000? Yes, it is less than 1000. Then it's gonna be displayed on the screen. So on the screen we see another one, and then f new will be calculated again. So let's do this. So the new f is 2 plus 1, that's actually 3. Now the marching, so the new f1 is f2, so f1 is 2, and the new f2 is f new, which is 3. We reach to the end, then we go back again to the beginning of the while. Is f1 less than 1000? Yes, it's just 2. We'll display it, so we'll see 2 on the screen, and then we calculate f new is 5, and then we will update the new value of f1 is just 3, the new value of f2 is just 5, and so on and so forth. So you see, you start, and of course the next thing will be displayed on the screen is 3. So you see, we are gradually printing the f1s, which are basically scanning all the values of the Fibonacci sequence up to less than 1000. Of course, less than 1000 because of this condition. Let's actually run this and see what we will get. So you see, you started obtaining 1, 1, 2, 3, as we just imagined, and then 5, and then 8, 13, 21, 34, 55, and so on and so forth. So you see, you are actually printing up to 987. Obviously, the next Fibonacci sequence is just more than 1000. I will leave it to you as an exercise to actually redo the same code, but maybe try to base it on f2 so that you display f2 and you make the condition based on f2. You will likely need to do some display before the while. Then let's see if this will work for you by displaying f2 and making the condition based on f2. Thank you so much, and see you in a